YouTube, Electric Adventures here with the next episode in Electric Adventures, the games. Where we left off, we did Artillery Fire off Program Pack 9 last time. So the next one, so this is a collection of probably a lot smaller games, but they're interesting nonetheless. So the next one is tennis. So this one's pretty much a pong clone, so let's run him. It's a very small program. So we just have our title, press trigger to begin. And I do believe it's a two-player only game. Alright, and as you can see, we've got some very simple ball physics going on. Just trying to think what the second player. So player 2 just won a point because I missed. The collision detection's way less than I thought it was. Oh, I went past that time, so there must be a little bit of an error. Yeah, it's going to go past there now. And keep on going. Oh, there we go. So the collision detection is a little, shall we say, could be done for, yeah, it's a little bit of a forgiveness on the top, which is also fair for my player as well. And I'm not sure whether I can change the angle of the ball much. Let's see. No, that's ended up in pretty much the same spot. Yes, it does have bat edge detection, so if you hit it on the edge, it changes the angle of the ball slightly. So that's going to go under. So as you can see, it's very, very simple. No sound effects whatsoever. So this is probably going to be a very short episode, and obviously a two-player game only. So hang on a sec, I'll set up the source code and we can have a look together. Okay, so we've rebooted again and loaded our source code, so let's list and see how long it is. This is not going to be very long. Okay, there we go. It is 17 lines long, so this really isn't going to take a long time to cover. So let's take our time a little bit. So, but there's still a lot on every line. So obviously line 10, we clear a bit of space, we set it standard colour, we set our screen mode, we make all the variables integer, which makes everything run faster. We define our random function, and we open our handle to the actual screen, which allows us to print text. Line 20, we set some slightly different colours. And by the way, the colours are, the three different values are the foreground, background and border colour. We set a slightly different screen mode. We dim a variable dim, so S2, so there's two places in that. We make a specific string of 16 characters, well, 16 values, so and all one of them are 192. That's going to do our bat. Remember, our bats were vertical, so it's just the same bit set all the way down the shape. So no data needed to make their sprite shapes, and we set our sprite shape 0 to be that. And we have a second sprite. Once again, we don't need data for this, it's only a little ball using exactly the same bit pattern. So two lots of that will make a little tiny square ball up at the top of the sprite. So line 30, we clear our screen, we put set colour to 1, which is black. Put our word tennis with space in between it, set a spot, print it, set a spot slightly offset by 1 pixel and print it again, so that gets our slightly thicker text. Go to a different spot, change our colour to 4, can't remember what colour that is, and we press trigger to begin. Line 40, we are basically waiting for either the any of the triggers, so either the keyboard spacebar, the trigger in joystick port 1 and the trigger in joystick port 2, and otherwise we just loop around in a circle. So once that happens, we clear the screen and we draw a box around the screen, and then we draw another box slightly, well, no, that's not around the complete screen. We draw a box at the top and a box at the bottom, so there are two upper and lower boundaries. And then a box in the middle, which basically does our colour infill in the middle. Line 50, we put the player 1 sprite and the player 2 sprite. and then we decide a random number between 1 and 2, so deciding which player is going to serve, and we put the ball on one side of the playfield or the other at a random vertical position. So we're doing 96 pixels high, which is not the whole screen, plus 16, so it's going to end up in that middle area. We set our X velocity, so there is a little bit of maths in here, based on the direction of the ball. And we set our Y velocity to be it can either be a smaller or a larger angle. So by a random, the random number is not determining the whole thing, so it'll be 1 plus potentially another 2 to get a slightly different angle. We set up our player scores, that's S1 and S2, go sub with 60, which probably I'm guessing is going to display those scores. Now let's have a look at our next few lines. Right, so line 60, we look at both the keyboard and joystick port 1 and the stick directions, and we're looking at A equals 1, which is up, and we make sure that our current Y position isn't already at the top of the screen, and if it isn't, we decrease the direction. And we're only changing one value, so I'm using vpoke and vpeak, which is a lot quicker than doing a full put sprite command. Line 70, we're looking for A equals 5, which is down, and to make sure that we're not too far down, so we're checking our bounds before we move, and then we just adjust the value so we're 4 pixels lower. So that's why the bats move fairly quickly. And then line 80, we look for joystick port 2, so it is definitely only a 2-player game. And we do exactly the same thing, but with the second sprite. Line 80 does the up direction, line 90 does down direction. So line 100, so if the ball's off the playfield, we decide the random starting conditions again, so that serves the ball again if it has disappeared. So line 110 basically moves our ball based on the current velocity setting. So we're getting the current X position, grabbing the velocity, multiplying that by times 6 and adding it to X, and the same with Y. So that's why the ball moves quite fast, so it's 6 times whatever the current velocity is, which I believe can be 1, 2 or 3. Then we're using the point command, which basically tells you what the colour of a particular point on the screen, and I think that's looking for the black at the edges. Yeah, so colour 1 is black, so it's looking for the black on the right or left hand side of the playfield, and it reverses the velocity. Line 120, depending on if the ball's going in direction 1, and we're a certain way across the screen, then we go and see whether we've hit the bat of the player. And as I said when I was playing it, then it is a little out on the top thing. So this calculation could do with a little bit of tweaking. Those that are interested, that's your homework for this episode. The source code of this will be freely downloadable. I'll put a link down below. Line 130 does the same thing, but for player 2. And obviously I reckon our go sub 160 is going to display our current scores. Line 140 puts the ball at its new position. So whatever X and Y has been changed, we use the put sprite command here because we're changing 2 things. Line 150, we'll loop back around to 60, which is our entire game loop. So we're only going to have 2 more lines to this program. So line 160 displays our scores. So it puts player 1, player 2, and then puts that out twice, so it's bolded, so 1 pixel offset. And then line 170, it goes and puts the actual scores next to those as well in a different colour. And that's our entire program. So I would say this did not take me very long to write back in the day. I probably wrote it as a fill-in game, probably specifically for this program pack. I can't remember exactly, so I probably had this program pack and I thought, oh, I need to add just a little bit more to make it worthwhile. And yeah, as I said, the games on this program pack are a little bit smaller than some of the others, but you got 4 of them, so good value. But an interesting game that has a little bit of simple maths and physics on there for you. So no acceleration and gravity or anything like that, but it demonstrates ball bouncing physics. And they're only very simple, and it's written in BASIC, so the tolerance is not very good because you're moving at such large, chunky things. It's a bit hard to make the collision detection accurate. But maybe you guys can have a play and make it better. I wrote this a very long time ago. Alright, I really do enjoy making these videos about my games that I wrote back in the mid-80s. I'm Electric Adventures. Thanks to all my subscribers. Thanks for watching, and I'll catch you next time.